And their neighbors actually woke up and went to the bathroom and saw the house all.
All right, well, so today what we're going to do is we're going to walk through a few practice problems. As far as the exam goes, so on campus we'll take it on Thursday, and I'll make it available online, so it'll be available for the students online on Thursday as well. And what you'll see is, I guess it would help if I would maybe get a little more light on this.
I have a virus on my computer, sorry.
Sorry, I'm trying
Do we need to do an attendance, like a...
No.
Okay.
I don't think there is attendance on the exam review day. So, which therefore might account for the fact that there's several people not here.
Can I ask who gives a 79.5 out of 100? Just as a teacher, like really?
Yeah.
They do that? Like they just couldn't go up to an 80? Like,
Well, the deal is if you're using a grading rubric, right, and you walk through and you go, okay, well that was worth 5 points and you got half of it, so there's 2.5 points. So that's how it works for me when I use a grading.
it's like they wouldn't just bump it up though? Like really? Like,
Well,
there it
at the
is.
end of the day, it probably does, but your grade for that particular assignment won't. All right, so just to refocus this, so we're going to do some practice problems here today. I'll post the blank practice problems online with a PDF of the solutions as we go through them here today. The exam problems are about 103 points of problems and about 50 points of multiple choice. So that'd be 25 multiple choice questions, 2 points each, coming directly from terminology. So use your Quizlet and prep. Okay? So if you're prepped with Quizlet, the terminology should go pretty quick and pretty easy, and you're going to want it to because you're going to have a time constraint then on the problem side of it. So you're going to want to make sure you have plenty of save your time for the problems.
So what did you say there was going to be 100 points of...
Roughly 100 points of problems and 50 points of multiple choice, which relates to 25 multiple choice questions worth 2 points each. And terminology from the end of chapter 3 and the end of chapter 5, right? Those are the chapters. Bring a calculator with you, right? Bring a non-programmable calculator with you, right? And it will be closed book, closed note, so there won't be any, you won't have any formula sheets or anything like that to use, okay? All right. So let me telescope in on this a little bit so then you can read it. So a fast food restaurant finds that the average number of people waiting in line during lunch hour is 20. On average, during this period, 4 people per minute leave the bank after receiving service. So there's a mixed problem, but you'll get the point. On average, how long do customers wait in line? So what does the 20 people waiting in line, what is that? What's the problem about? Inventory, right? So the problem's going to be about Little's Law, right? And Little's Law says what? It's going to be a hard exam if we can't figure out what Little's Law means.
Inventory equals throughput times time.
Yep. Inventory is equal to throughput times flow time. Okay. And so we just said that's inventory is 20, and so it's 20 customers. Okay. On average, during this period, 4 people per minute leave the bank after receiving service. So we'll change that to restaurant. But so 4 people per minute is what?
The
Throughput.
Yeah.
Right. Or 4 customers per minute. So if I then need to know how long they wait in line, I'm going to use my formula of inventory equals throughput times flow time. Solve for time, which is throughput divided by inventory. So 20 customers divided by 4 customers per minute should equal
The
5.
formula should be inventory divided by throughput, which is what you did with the numbers.
You're right. Rachel's my correcting.
She's that girl.
Inventory divided by throughput. Okay, so 20 customers divided by 4 customers per minute. Okay? So the next one, the next kind of basic Little's Law problem says, a company processes 15,000 in accounts receivable per month. Average outstanding accounts receivable is a balance of 45,000. What's the average time that a dollar spends in this process? So Hunter,
Yes, ma'am.
so what does the 15,000 represent?
That's how much they can process in accounts receivable per month.
Okay, so in Little's Law, what does that represent?
It would be your throughput.
Okay. So 15,000 per month. Kaylin, what's the 45,000 represent?
The accounts the inventory.
Yep. So inventory is 45,000. So what's the average time that a dollar spends in this process? So again, time is equal to inventory divided by throughput. So inventory is $45,000 divided by 15,000 per month
3 months.
is equal to 3 months. Okay, so these are kind of warm-up problems, right? So you can expect to
A whole bunch of these.
This will be very similar on the front page of the exam. You're just going to have a few warm-up problems like this. Okay? An insurance company has on average 6,000 claims in process at any given time. On average, it takes 2 weeks to process a claim. What's the throughput for this process? So, Zach, what are the numbers telling me in this one?
6,000 claims in process at any given time is the inventory.
Say that to me again.
The 6,000 claims in process at any given time is the inventory.
Okay. And Andrew?
2 weeks is your time.
So there we go. So my throughput is going to be 6,000 claims divided by 2 weeks. That's 3,000 claims per week. All right, and the thing about this is you need to make sure that you use the unit of measure, right? Because if you don't use the unit of measure, I'm going to take off a point. So make sure you use, so if you use the wrong unit of measure, you lose a point, and if you have no unit of measure, you lose a point, because it's not fair to the people that make the attempt to get it right, and for me to give you credit for not putting it.
So what was that, 3,000 units per week?
All right, then we go into just a little bit a more detailed Little's Law problem. And it says, during tax season, customers arrive in an accounting firm to have their taxes done at the rate of 10 per hour and are able to leave at the same rate. So what does 10 per hour represent?
Throughput.
Throughput, right? Okay, so I'm going to go 10 per hour, 10 customers per hour. Each customer waits in line to meet with the receptionist, who then assigns a tax consultant to prep each customer's tax return. Okay, so then the customer waits to meet with the tax consultant and completes the tax return process. On average, 2 customers are waiting at reception. So I usually just write right above that buffer that there's 2 customers there, right? And on average, 1 customer is waiting to see a tax consultant. Okay. It takes the receptionist a quarter of an hour to complete a client's registration. So that's a quarter of an hour. And it takes a tax consultant on average 1.5 hours to complete the tax return. All right. So the first question says then, based on the information provided in the problem, complete the information in the table above. The unit of measure for flow time is hours, and the flow unit is a customer. All right. So Rachel, just walk me through, how would you begin to fill this in?
The inventory is 2 customers, buffer 1's inventory is 2 customers, and buffer 2's is 1.
Mm-hmm.
And then the registration flow time is 0.25, and the tax return is 1.5, and then it's 10 for your throughput on all 4 steps.
Mm-hmm.
Well, 5.
Okay. And my throughput for the total process is what?
10 customers per hour.
Right. So again, just remember that the throughput isn't summative, right? So now that I've got that, how do you solve the table? I'm going to let you keep going.
You follow your formulas. So for the flow time, it's inventory divided by throughput.
Yeah. Inventory divided by throughput. So 2 divided by 10 is 0.2, right? and 1 divided by 10 is 0.1. Okay. And for my registration, inventory is throughput times flow time, so 10 times 0.2 is 2.5. Okay. And 10 times 1.5 is 15. Okay. And so, can I sum my inventory and flow time in this problem?
Yes.
And why is that?
Linear.
It's linear, so I can sum, right? So I'm going to go 2, 3, 5.5, and 15 comes up to 20.5, right? And 0.2 and 0.1 is 0.3, plus 0.25 is 0.55, plus 1.5 gets us to 2.05, and again, this is hours, and this is customers. Okay, and then the questions say, so we filled in the table, right? So, Emily, going to come back up to you. On average, how many customers were in the total process?
20.5.
Great, 20.5 customers. And Emily, on average, how long did patients spend in the total process as described above?
2.05 hours.
There we go. So again, pretty straightforward Little's Law one, right? Hunter, what's your question?
When we put those up on the table, do you want us to relabel those, but since they're already labeled up top, or do you want us to do just like that?
I encourage you to put the labels at the bottom on this particular problem because they're already up there. I won't take off if you don't.
Okay.
But just for habit.
Is it going to be set up the same?
Yeah, I think it will be. I haven't written the particular problem yet, but
Okay.
again, I'm usually not very creative when it comes to writing my problems. They look very similar to what you see. In part because I don't think this isn't about being creative. This is about, do you understand the work that we've done, and can you
method.
Can you repeat it? Right? Okay. So the next one, a little longer, a little more complicated. So a transportation company has a process where they are required to check in drivers upon their return from their route. They have conducted a study and have determined that 80% of their drivers' logs match their onboard computer equipment. The remaining 20% of the drivers' logs do not match their onboard computer equipment, and a manual reconciliation process must be completed. Previously, the driver check-in process was completed on a first-come, first-served basis. This process took approximately 50 minutes on average to complete. A new system was designed which separates the processes into 2 areas, one for routine driver check-ins and another for driver check-ins which must have a manual reconciliation completed. Okay? So the driver check-in process consists of the driver arriving at the terminal and waiting to see a clerk, so that's buffer 1, okay, who completes the initial inspection to determine if the driver's logs match the onboard computer equipment. The clerk then routes the drivers to the appropriate dispatchers to complete the check-in process. So buffer 2 goes to dispatcher routine check-in, buffer 3 dispatcher manual reconciliation. Okay. On average, 30 drivers per hour enter the driver check-in process. So I'm going to write at the beginning that I have 30 drivers per hour, right? And that I know coming out, I need to have a total of 30 drivers per hour. But you can see we've got 2 arrows coming out, so those 30 drivers per hour are going to be split across those 2 legs of the process. Okay? So assume the process is stable. The clerk inspection takes on average 2 minutes. All right? Scotty, where's the 2 minutes going?
The clerk.
Okay. And the routine inspection process takes 15 minutes. Okay? And the manual reconciliation takes 45 minutes. Okay? So 2 minutes. There are on average 5 drivers waiting for the clerk inspection. So I've got 5 drivers here. 2 drivers waiting for the routine check-in. And 2 drivers waiting for the manual check-in. Okay? So Scotty, help me fill in the table from what we just did.
Okay, buffer 1 is 5, buffer 2 is 2 for inventory, and buffer 3 is 2 for inventory.
Okay.
And then drivers per hour, it's 30, 30, and then 24, 24, and then 6, 6.
And how did you get the 24, 24?
Buffer 2 and routine, there's 80% of the drivers go that way, so you have to multiply by 0.8.
Okay. So 80% of 30 is 24, and 20% of 30 is 6. So that's exactly right. And what's the total coming out of that process then?
30.
There we go. All right. And then let's keep going. Where else do we need to fill in?
2 at the clerk for flow time, and then 15 at routine and 45 at manual.
15 at routine and 45 at manual. Okay. All right. And so you'll notice that we have 1 unit of measure in hour and 1 unit of measure in minutes. So we need to convert to minutes. Okay. And so 30 drivers per hour. How many drivers is that per minute?
45.
Yep. If I were going to do the math on that, I'm going to go 30 drivers per hour. And if I want to cancel out hours, so I need 1 hour in the numerator and 60 minutes in the denominator. So I cancel out the hours, and that gives me 30 divided by 60, which is 0.5 drivers per minute. You just need kind of a refresher on how we get there. Okay, so I have 0.5, 0.5, okay. 80% again is 0.4, 0.4, 0.1, 0.1. Okay, and again, my total here should be what?
0.5.
0.5. Okay, and now it comes to, you're just filling in the table. Inventory is throughput times flow time, and flow time is inventory divided by throughput. Okay, and so Hunter, what am I multiplying to get my flow time for buffer 1?
Going to be your 5 times, since it's in minutes, times your 0.5. When it, or no, oh no, it's a division. Yeah, it's the 5 over the 0.5, so it's the driver inventory over the throughput in minutes.
Yeah, 5 divided by 0.5 is 10.
Which is actually multiplying by like 2.
2 divided by 0.4 is 5. Okay, and 2 divided by 0.1 is 20. Okay, and then to go the other way to get how many drivers are in inventory at the clerk, right? I'm going to take throughput times flow time. So 0.5 times 2 is 1. 0.4 times 15 is 6. And 0.1 times 45 is 4.5. Okay. And so, Hunter, what am I going to do to finish out this table?
You have to do like the weighted average because it's not a linear process.
Okay.
The totals.
That's one approach, and I'd say that's the longer approach. Can we add the inventory here to say how much inventory is in the total process? Yeah. So we can add the inventory. And so we can say we've got 20.5 in the total process. So if I'm looking for the time, you're right, I can't just add the time.
Oh, you can just do your equation though on the bottom one.
Yep, I can use Little's Law, right, and say that inventory of 20.5 divided by 0.5 is going to leave me with 41 total minutes on average. Okay? So, again, we get this by saying flow time is equal to inventory divided by throughput. We have 20.5 drivers in the process. And we're going to divide that by 0.5 drivers per minute. Which then equals 41 minutes. So Kaylin, now we've got some questions to answer. So what I'm going to do is I'm going to leave this table showing, and then we're going to answer the questions. So on average, how many drivers were in the total process?
20.5.
20.5 drivers. On average, how many minutes did drivers spend in the routine process? So if I'm just interested in the routine process,
41.
that's in the total process. So it's asking you how much did they spend in the routine process. So if they go through the routine process, right, they're basically going through these steps, right?
Okay.
So what you need to do then is just add up the time that it takes at each of those steps.
So 17.
So it's going to be 10 plus 2 plus 5 plus 15. Right?
Yeah.
So 12 and 5 is 17 plus 15 is 32 minutes. Is everybody tracking with how we did that?
No. Oh, yeah.
All right. And then the next question is, on average, how many minutes did drivers spend in the manual reconciliation process?
What was the answer to that? 30?
32. So how many did they spend in the manual reconciliation process?
77.
What's that?
I think it's 77. If
You
I
think
add
it's-
it right.
Be 10 plus 2 plus 5 plus 2
If I
plus
add it
20
right.
plus
You
45.
did.
Okay.
So tell them how you got there.
You do the 10 buffer 1 plus the clerk, and then you add buffer 3 and then manual.
Right. And so then basically you're saying, okay, well, how much time did it take to go through this path of the process? So you're adding up those steps, right? So,
Should be 12 plus 65.
right. And so that's a total of 77 minutes. Okay? And so on average, how many minutes did drivers spend in all types of check-ins?
41.
41, right? Okay. Is this revised process better for the drivers? Why or why not? It is, and why would we say it is?
Because it used to take 50 minutes.
On average, it used to take 50 minutes, and now on average, it takes 41 minutes. Okay.
This one's 41.
Yeah.
All right. That one everybody got a pretty good handle on that? Any questions on how to approach that one?
It used to take
How'd you answer number 5 again? What was the on our?
How many minutes? So what you're doing basically, Zach, is you're looking at the process and you're saying they're only asking me about a certain part of the process. And so if that's the case, when they say the routine check-in, what I'm going to do is pretend like I'm the flow unit and what steps do I have to go through? And then I add up the time of each of those steps. So the routine process goes buffer 1, clerk, buffer 2, dispatcher. So I add up buffer 1, clerk, buffer 2, and dispatcher, and that's on average how long it takes someone to go through that phase of the process. Okay. And then when it says, okay, well, what about manual reconciliation? Okay, well, they go through buffer 1, clerk, buffer 3, and dispatcher. So then it's buffer 1, clerk, and then these two, buffer 3, and the manual reconciliation. Okay. When we ask about the total process in a non-linear process, right, we have to use Little's law to get the time, because we can't just add it up, because not every unit goes through every step of the process. Right. 80% of them go through the routine and 20% of them go through the manual. Okay? All right. Okay, so our next practice problem is about Shelby Manufacturing. Shelby Manufacturing specializes in 2 types of production. The typical work involved in each product type is quite predictable and repetitive. The time requirements or unit loads for preparing each type of product are shown in the table below. The contribution for product A is $2,000 and the contribution margin for product B is $1,800. Also listed are the number of resources of each type and the number of hours each day the resource is available. Okay, so you can see we've got an assembler, a shipping person, and a manager. Okay, and so our unit load for type A, product A, is 10 hours per unit for the assembler, 2 hours per unit for shipping, 2 hours per unit for managers. Okay, unit load for assembler, 6 hours per unit for assembler, 6 hours per unit for shipping, and 2 hours per unit for the manager. Okay. We have 8 assemblers, 6 shipping people, and 4 managers. The assemblers are each available for 6 hours per day. Shipping is available for 8 hours per day. Each shipping person is available for 8 hours per day, and each manager is available for 4 hours per day. Okay. So the first thing is, what is the effective monthly capacity of the resources at the current product mix? Okay. All right. Well, what we know is that we've got 50% of unit A and 50% of unit B. So, where am I at? Am I back to Hunter, maybe?
No, you just passed Kaylin.
Okay, so, Andrew, what's the first thing I need to do in this type of a problem?
That's a great question.
Okay, yeah, so who feels like you can kind of walk us through what we need to do? Rachel, can you walk us through that?
You've got to get the unit load that's in weighted average, or this one an average.
Right. And so in this case, I need to get an artificial unit load, right? And so my artificial unit load for assembler, shipping, and my manager, right, are going to be 10 times 0.5 plus 6 times 0.5, right? For assembler. For shipping, it's going to be 2 times 0.5 plus 6 times 0.5. And for manager, 2 times 0.5 plus 2 times 0.5. Of course, I imagine you all can do that maybe faster in your head, but I want to show the math on how we get there. So my artificial unit load, hours per unit, right, is basically the average between these two, and I'm hopeful. 10 and 6 average is 8, 2 and 6 average is 4, right, and 2 and 2 average is 2. Okay. What's the next step in this type of problem?
Do we have to find the reciprocal?
Yep, we have to find the effective capacity.
What do you label the 8, 4, and 2 as?
Hours per unit. And so now effective capacity is units per hour. And it's 1 over 8, 1 over 4, and 1 over 2. So it's 0.125, 0.25, and 0.5. Okay. So I've got my effective capacity. Okay, so if I'm trying to get to my monthly, I've got how many units per hour I can do, right? And so we need to convert that into a daily capacity and then into a monthly capacity, okay? So I'm going to take it times the number of resources of each one that I've got. So I've got 8, 6, and 4. And the number of hours that they're available each day. Okay. And so they're available 6, 8, and 4. And we're assuming in this problem that we have 20 days per month. Because if I'm trying to get to monthly capacity, I'm going to have to do that. So then my effective monthly capacity is 0.125 times 8 times 6 times 20, which is going to equal 120 units per month. Okay, and then for the shipping personnel, it's going to be 0.25 times 6 times 8 times 20, which is going to be 240 units per month. And for the manager, it's going to be 0.5 times 4 times 4 times 20, which is going to equal 160 units per month. Okay? So we've answered A, right? So when it says, what is the effective capacity of the process at the current product mix? What's our effective capacity? Zach, what's our effective capacity? 120 units per month, right? Okay. Can the company process all 150 orders in the month of March? Zach says no, he's right. Given the current product mix, what's the bottleneck? Zach, tell me. Assemblers are bottleneck, right? If the firm wishes to process all 150 orders, how many employees of each type are needed? Okay. So, do you remember how do we track that down? Do you remember how we would track down? Let's just look at the assembler. So if I was going to say on the assembler, how would I determine how many assemblers I would need?
Whatever capacity you need.
Okay, so I have to figure out the capacity that I need first, right?
So you want 150.
So I need to do 150 orders, right?
Yeah.
So I'm going to pull this off and I'm just going to write on here. So for the assembler, to do 150 orders, how many hours per unit does it take an assembler?
0.125.
Hours per
8.
week is it?
Oh, yeah, I'm just doing units per hour.
So it's times 8 hours per unit. Okay? So that tells me that for the assembler, I need 1,200 total hours. Okay? And then I need to, for one assembler, how many hours are they available in a month?
6.
Oh, not today.
240.
Okay, and so they're available 6 hours per day times 20 days per month. Gives you 120 hours per month. So how do I close this problem then? Because I need to know how many assemblers I need to do 150 orders.
You need 10.
And how'd you get that?
1,200 divided by 120.
So the number of assemblers needed is equal to the number of total hours needed to process 150 divided by the number of hours that one assembler is available. Per month. Okay, so that becomes 1,200 divided by 120, 1,200 hours divided by 1,200 hours per month gives us 10. Sorry, that kind of drug off there. Right, so now we're just going to repeat that same thing for how many managers do we need. Okay, so for the manager, to do 150 orders, how many hours does a manager spend on an order?
Four.
Two.
Two.
Okay, so times 2 says that managers need 300. We need 300 hours of manager time. And a manager, so one manager, to keep it kind of consistent with what we did above, how many hours are they available in a month? Okay, so how many hours is a manager available, one manager available per day? How many of their hours are 4? So 4 hours per day times 20 days per month says that one manager is available for 80 hours per month. Okay, and then again, how many managers do we need? So we're going to take the 300 hours that we need and divide it by the 80 hours that they're available, and that's going to tell us that we need 3.75 managers.
Dr. Betts, would you just round that up to say 4 managers?
Nope, you wouldn't, because you would assume that they could work someplace else part-time too. I mean, if they're only working here 4 hours a day, it's telling you that they're doing other stuff for 4 hours a day, typically. Okay, so you would not round up. Okay, and then if we looked at the shipping, to do 150 orders at 4 hours per unit, says that 600 shipping hours are needed. Okay, shipping availability. They're available for 8 hours per day times 20 days per month. So it's 160 hours per month. And so then number of shipping personnel needed is going to be 600 hours divided by 160. And that's also going to be 3.75. Okay, so that answers, if I get back to the problem, so we've now answered A, we've answered B, we've answered C, we've answered D. So then E says what type of product is most profitable and show how you determine this. Okay. So if I'm looking to show how it's most profitable, can I continue to use my artificial unit load? You can't. Okay. Do you remember when we just reviewed this in Chapter 5? As long as you're talking about the combined product mix, you can use the artificial unit load. As soon as the question reverts to compare two products, you have to pull them apart and you have to get the unit load for each product. Okay? And this is going to be just like that homework that you did last week. This is going to be where we dive into it and say, okay, well, I need to then look at each of those individually. And so I'm going to set up my table just like we would have before, right? For product A, I'm going to have my assembler. I'm going to turn it like this just so I can write level. My shipping and my manager. And for product A, my unit load is 10, 20, and 2, right? Okay, and we're talking about hours per unit. So then I convert that to effective capacity, which is 1 over 10, 1 over 2, 1 over 2, which is 0.1, 0.5, and 0.5. And my effective capacity is units per hour. Okay. And then we keep finishing it by saying how many resources. Okay, so we have 8 assemblers, 6 shipping personnel, and 4 managers. Okay, and they are available, hours available per day. It's the assemblers available for 6, the shipping people are available for 8, and the managers available for 4. Okay, and so if I want to know how much they can do in a day, right? I'm going to take 0.1 times 8 times 6. It's going to give me 4.8. I'm going to take 0.5 times 6 times 8, which is going to give me 24. It's going to give me 0.5 times 4 times 4, which is going to give me 8. So in this example, for product A, what's the most product A that I can produce in a day?
4.8.
4.8, right? And in the problem, it tells us that our contribution margin is $2,000 per unit. So that tells me that my contribution margin for working on product A all day is going to be 4.8 times 2,000 or $9,600. Okay? I need to now compare that to product B. Okay? And so basically we set the table up exactly the same. Right? And for product B, our hours per unit are 6 for assembler, 6 for shipping, and 2 for managing. Okay, my effective capacity then is 1 over 6, 1 over 6, and 1 over 2, which I've already done the math. If you don't mind, we'll just go 0.167, 0.167, and 0.5. Okay. We still have 8, 6, and 4 available. They're still available for 6, 8, and 4 hours per day, respectively. So then we do the math. 1.67 times 8 times 6 is 8.016. And again, 1.67 times 6 times 8 is still 8.016. 0.5 times 4 times 4 is 8. Okay? So what's my capacity for product B? 8 units per day, right? And my contribution margin is $1,800. So that's going to be $14,400 is going to be what I can contribution margin per day. So which is more profitable, product A or product B? Product B, right? Okay. All right. The last question on this particular problem asks us, at the current product mix, what is the value of hiring an extra assembler each month? So if I'm at the current product mix, am I using individual unit loads or the artificial unit load?
Artificial.
I'm going to use the artificial unit load. Okay. So the question is, and we've already calculated, right, what we can do. And the question is, per month, what's the value of hiring an extra assembler? Okay. And so our approach here is we need to look at the assembler, right? And we need to say that an assembler is available for 6 hours a day and 20 days a month, right? So that tells us that our assembler then would be able to do 120 hours effectively, right? So one assembler for the month can do 6 hours per day times 20 days per month. So they're basically available for 120 hours per month. And to quantify that, right, I'm working with my artificial unit load. So I need to create an artificial contribution margin. Okay? So my artificial contribution margin is 50% of 2,000 plus 50% of 1,800. Okay? And last time I checked, the average of that would be 1,900. Okay? And so, but to think about then, what's the effective capacity of an assembler? Okay? And again, we've already calculated that. So we're going to flip back to the chart where we calculated that. And we can see that the effective, we can do 0.125 units per hour. Okay? And so if we can do 0.125 units per hour right, times 120 hours that they're available in a month, times our artificial contribution margin of $1,900 for each unit that we produce. Because this is going to get us how many units we can produce, and this is going to get us our contribution margin per unit. Okay? And if I finish that math out, it comes out to be 15 units per month. Right, because our hours cancel each other out. Times 1,900 is 28,500. So basically what you end up saying is if we would hire an extra assembler if it costs us less than 28,500 a month, right? Because we would get that much more in contribution margin. Okay? Those are going to be, you may want to run back through and do the practice problem and then go back and look at your homework because these are going to be just like the homework problems that you did as well. So make sure you walk back through those. Okay? And then the last one is kind of an easy one again. Yeah, that's probably the harder one on the, okay. And so you're given a table and it says, given the effective capacities of the resource pools and their associated capacity waste factors that are shown, please indicate what the theoretical capacity of each resource pool would be, okay? It requires you to know that your theoretical capacity of the resource pool is equal to the effective capacity divided by 1 minus the capacity waste factor. Okay? So in this case, for the paralegal, it's going to be the effective capacity of 5.5 contracts per day divided by 1 minus 0.2, right, equals 6.875 contracts per day. And you don't, here's the thing.
Oh, we're going to theoretical. We're not.
What's that?
I thought we were doing theoretical in the waste factor that was there to get effective. And I was doing it that way.
Okay.
I went through it.
If you have time, show me your work, because I'll give you partial credit if you do a math error, but you have it pretty well set up right. But if you don't show me your work and you just write in your answer, it's either all or none. Okay? So I encourage you to show me your work and label it clearly so I can follow it.
Even if we did slip up on something like that, we get some points.
Yeah, exactly. Okay. I mean, this one is not a big one. I mean, it's a 5-point whopping. So, if it's a calculation error, I usually just take off a point, right? So.
It was just I was doing the wrong thing. I wasn't reading, and I was just like, oh.
So, and so again, then this one would be 10 divided by 1 minus 0.3, so that's 14.3. And this one would be 7 divided by 1 minus 0.35, which is 10.8. Okay? What questions do you have for me? Any?
Do we get a formula sheet like we did for the last one?
I don't think you need one for this one.
Can we,
What's that?
just a sheet in general. It's like a half page.
Nope.
Be really
There's not that much to memorize. If you've done your homework, you've been after it, then you know how to walk through them. Little's Law is pretty straightforward, right? Inventory is throughput times flow time. Any questions? Okay, I'll see you back there on Thursday to take the exam. You're all going to rock it. I know
That's
it.
right. Everybody gets an A, right?
And then the 2 days after are the work days, correct?
Yep, so the following week is the work days. So, and those work days are meant to be on Part C. So if you're still on Part B, you need to kick it into higher gear. And then for the team in here that finished Part B, I should have that graded by Thursday. So you'll have the feedback by then. I've been kind of waiting, thinking I'd get another one in to look at with it, but.
She'll have Kirby.